Two people, same room, same virus. One wakes up with a scratchy throat. The other feels completely fine. We've all seen this happen. Most of us have experienced both sides. For decades, the explanation was vague. Different immune systems. Some are just more resilient, but a new study from Yale School of Medicine opens the black box. The answer lies in a place we rarely think about, your nose. Rhinovirus is the most prolific pathogen. It causes 30 to 50% of colds globally. This virus infects billions of people each year. There are over 160 strains floating around. It survives on surfaces. It spreads through air and touch. No vaccine, no cure, no meaningful antiviral. For many adults, rhinovirus means misery, congestion, sore throat, and fatigue. For others, it barely registers. For people with asthma or COPD, rhinovirus triggers medical emergencies. It's the leading cause of asthma attacks. Understanding why some suffer more matters. Immunologist Dr. Ellen Foxman at Yale and her team built a human nose in the lab. They created a three-dimensional model from actual nasal stem cells. Over 4 weeks, it matured. Mucus-producing and ciliated cells developed, forming a living surface resembling a real nose. They then infected this model with rhinovirus. Using single-cell RNA sequencing, they observed what happened. When rhinovirus enters the nasal lining, it encounters type 3 interferon. This protein defends by signaling nearby cells. It alerts them to activate antiviral defenses before the virus reaches them. When this response is quick, the virus infects fewer than 2% of nasal cells. No symptoms are felt. But if the interferon response is delayed, the virus spreads, infecting over 30% of nasal cells. A second inflammatory response follows, leading to excess mucus and misery. Same virus, different outcomes, depends solely on the interferon response. When that defense fails, NF-κB takes over. This transcription factor amplifies inflammation. Under normal conditions, it regulates immune response. With rhinovirus unchecked, it escalates. More inflammatory cytokines are produced. Excessive mucus floods the airways. The immune system overcorrects itself, causing intense inflammation. Cold air isn't just uncomfortable, it gives the virus an advantage. Research shows rhinovirus replicates better at lower temperatures, like in your nose. A 2022 study demonstrated cold exposure can impair nasal immune defense systems. When nasal temperature drops, the warning signal happens later. The virus's spread gets a head start. What weakens your interferon response? Several factors are now clearer. Air pollution and smoke damage nasal defenses. Chronic exposure shifts them to pro-inflammatory mode. Cold and dry air slow antiviral signaling. Genetic variations impact interferon production. Recent infections can provide mixed effects. Pre-existing conditions can inflame the nasal lining, reducing immune responses further. Rhinovirus is crucial for people with asthma. It causes up to 85% of asthma attacks in children. For some, rhinovirus means hospitalization. Inadequate interferon response worsens asthma. This research opens new treatment possibilities. Targeting the rhinovirus directly is tricky. It mutates quickly. But amplifying the interferon response is promising. Intranasal interferon therapy may work by delivering synthetic proteins directly to the nasal passages at the first sign of infection. This research could shift how we treat colds. Even if proven interventions aren't here yet, understanding what weakens defenses is essential. You can limit exposure to pollutants and keep your indoor air humid. Stay warm, especially your nose. Manage allergies and underlying conditions. None are guarantees, but they support your nasal immune system. The common cold is a long-standing human experience. We've never had a true cure. We've thought of it inevitable. This research suggests otherwise. What happens in your nose determines your fate. In the first hours after exposure, your defenses need to react quickly. How we support this defense could redefine cold medicine. And for the first time, we know where to look. If this changed how you think about colds, share it with someone often getting sick. Follow for more science explaining your daily biology.